Okay, fine. We were talking. Can I? We were in the previously in this correct slide, if I am correct. Correct.
Yes, Professor.
Yes, Professor.
Yes, Professor.
Yes, Professor.
Yeah, we have talked what is a port fuel injection system. This picture is a very good. This one. Okay. Make what is the advantage? Already we have talked almost 2 or 3 classes. Correct. Atomization, pressurized fuel injection. Correct. Always helps in smaller droplets, smaller fuel droplets. Pressurized fuel, pressurized injection. Okay. That means increase the pressure of the fluid using a pump. Correct. There is a pump under which sucks the fuel. Correct. Sucks the fuel. There's a pump. Okay. This figure is it is missing. So you can add that this is a pump. Sorry, not here. Just let me add here. So the pump is here. This is the high pressure pump. Pump in some books, some figures, pump will be put after here. Correct. Sometime here also from the fuel tank, fuel is sucked by the pump and then filter will there. But in some books, the fuel filter will be first, then will be pump. Correct. So that's both are okay because even pump also just should not get clogged. Correct. First filter from fuel filter tank, fuel comes to filter, filter removes. Correct. After that, if you put the pump also will not get clogged. Correct. So fuel filter from this one goes come here, then high pressure. So that is one thing. As I already told you, there is no point again discussing. So pressurized fuel, if you inject, then the fuel smaller fuel droplets. So better fuel vaporization. Fuel vaporization. Correct. Happens, better combustion. Right. So which leads to better torque, engine torque. Correct. Then less fuel emission, tailpipe emission, toxic tailpipe emission. What are less toxic? This here it is very clear. CO, HC, and NOx. Correct. These are highly toxic, which is coming out of petrol engines. This one, if the combustion is not proper. Correct. When the air-fuel ratio is not in proper condition. Right. So what is the air-fuel? The air-fuel is not a proper condition. Whether it is stoichiometric air-fuel ratio, AFR. Already we know that it is nothing but 14.7:1 in case of petrol. Correct. I'm again repeating petrol. Does this stoichiometric air fuel vary for other fuel? Yes. If you go to methanol, ethanol, correct. Petrol engine can be run with alternate fuel, methanol, ethanol also, correct. Or any other hydrocarbon, like isopropane, all those things. For that, the air fuel, this stoichiometric air fuel is different. Okay, the air fuel ratio of other fuels other than petrol is not 14.7. It can be 11:1, 12:1, something varies. We have to see. Okay, but if you run your engine in stoichiometric air fuel ratio, correct, in stoichiometric air fuel ratio, correct, and if you have a catalytic converter, correct, you can see here. So if you maintain the air fuel ratio using proper fuel, this one closed loop control, correct. How will you achieve closed loop control? We are going to see that closed loop control. Control will help in maintaining stoichiometric air fuel ratio. How the closed loop control is maintained by EEGO sensor, exhaust gas oxygen sensor, correct. It measures the AFR, correct. It is used for measuring air fuel ratio of the engine, correct. But already told you, it doesn't measure air fuel ratio. Actually, what it measures is oxygen, amount of oxygen available in the exhaust gas. After combustion, if the fuel is not burned properly, or if you inject less fuel, correct? If you inject less fuel, then the stoichiometric, then we call lean mixture, correct? If lean mixture means the fuel air fuel ratio in gases, say for it is air quantity is more than the fuel quantity, correct? Instead of 14.7:1, you may have 15:1, correct? Anything greater than air quantity greater than 14.7 for one part of the fuel is called as lean, correct? It can be 16, 17, 18. All these things are called lean, correct? Already you will lean mixture, correct? In lean mixture, definitely you will get O2, correct? Because you have less fuel than the stoichiometric. That means the number of fuel molecules available, correct? What is that? H and C is less, which can be combined with O2, correct? Basically, you are supposed to get CO2, correct? If fuel is less, correct? So the number of oxygen atom are more in the air because you have more oxygen, because more air, because more oxygen, less fuel. So you will see that CO2 is coming out. CO2 plus O2 will be coming because carbon and hydrogen atoms are not available. So the oxygen comes out. That is what we're going to detect. The EGO sensor, exhaust gas oxygen sensor, correct, is exhaust gas oxygen sensor is called EGO sensor, correct? Also just says oxygen sensor, which is put in the exhaust stream, correct, which is nothing but your tailpipe, correct? This is tailpipe, which is connected to outlet port, right? Or engine outlet port, correct? So when this open comes out, so you, by measuring this, you are giving a feedback. What you are giving, you can see that the signal from the EGO sensor goes to SA input to ECO, correct? ECU, electronic control unit, correct? If it finds lean airfield mixture, what it do is the ECU, if you program it, if you wanted to maintain stoichiometric airfield ratio, correct? What engine ECU will do, it will inject, it will increase the injection pulse width, correct? So here the fuel is injected. How? As a fuel pulse, correct? This is the fuel injector voltage, which is called as injector pulse. Who is generating this? It is generated by the ECU. This pulse, if more oxygen available, correct, then the oxygen sensor gives a signal. Yes, more airfield is available. Based on signal, the pulse width may be increased, correct? The ECU will increase the pulse. So that means you can inject more quantity. The pulse width will become bigger, correct? Again, so for next cycle, what happens? Next cycle, the ECU will give a bigger pulse. You can see the blue color pulse, which is the width is bigger, correct? For example, this was 1.5 millisecond. Previously, it was 1 millisecond or something, correct? Red one is say 1 millisecond. It is gives say 1.25 millisecond. Generally, you will not make double, correct? You will increase by little quantity. Pulse width duration will be increased in the rough, maybe additional 0.1 millisecond, something like that, correct? Next cycle. That it depends upon the injector side, all those things that you have to create map. What do you call a mapping? I will tell you how it is. So more fuel is injected. Then what will happen? The more oxygen is consumed, less O2 will come out. Correct? Next cycle. So that is reported. Who is reporting? The EGO sensor says the amount of oxygen available in the exhaust stream is less. So that information again go to ECU in the next cycle. Correct? But still you see that there is some oxygen. What will happen? In the ECU, since it received information from the EGO sensor that there is still some more oxygen available. So, okay, what it will do? It will increase injection pulse still higher. I'll put in green color, correct? You can see that injection pulse will become bigger. Next cycle, correct? Engine cycle. So now you can see that this is injection duration. So it can become 1.5 millisecond, correct? This was 1.5 millisecond. This is 1.2 millisecond. Originally 1 millisecond. Correct. So first cycle was 1 millisecond. That time oxygen level was more. EGO sensor has more quantity of oxygen coming out without combustion happening. That means ECU knows that it is injecting less fuel. So what it will do? It will command the injector to open for more duration. So instead of 1 millisecond, it will inject for 1.2 millisecond. Next cycle. Correct. So next cycle. Okay. Again, because after combustion, the exhaust is coming out. Correct. So the sensor again detects. So it sees that still oxygen is available because which is not combined with fuel molecules. So what it will become pure O2, it will come out. So if pure O2 is out, the sensor is there. So that information goes to ECU. correct? So ECU again increased to 1.5 millisecond fuel injection duration. That's why this pulse width is called pulse width modulation. I told you, correct? Pulse width modulation, correct? That is nothing but PWM, pulse width modulation, correct? So the fuel quantity increase or decrease by varying the injection duration by the ECU. Every cycle it checks. So now how once it reaches the oxygen level becomes less, correct? The oxygen sensor gives a signal, electrical signal, which says that there's no oxygen in the exhaust stream. Correct, almost oxygen is nil. Then what it will do? It will stop injecting. It will stop there. Correct. So suppose reverse also can happen. Suppose you are injecting 2 point when starting itself, your ECU gives 2 millisecond pulse. Correct. The duration is 2 milliseconds. Correct. So it is now when you see that there's no oxygen at all, oxygen is stopped. Absolute no oxygen is gone. That means you are injecting more fuel. Correct. Fuel quantity more than the oxygen available. So all the oxygen molecules are used already by this. Excess CO this. HC is coming, unburned fuel, correct? That means no oxygen available because you have a sensor called HC sensor. There's a separate sensor, but oxygen sensor doesn't detect. It sees that there's no oxygen. But what the ECU will do is next time instead of 2 milliseconds, it will reduce the fuel injection pulse to 1.5 milliseconds, something like this. You can see here bottom I am drawing, correct? So it will draw 1.7 millisecond. So this width is 1.7 millisecond. Originally it was 2 milliseconds, correct? I said 2 milliseconds. So it will reduce next cycle, correct? Again, the combustion, this one is coming out. The O2 sensor says that still fuel quantity, no oxygen. So next cycle, what ECU will do? It is you have to program, correct? As a programmer, you have to do. ECU should be programmed. So what you will do? You will make in next cycle the fuel pulse which should be still lesser. What I do? I will make a pulse which is 1.5 millisecond, correct? 1.5 milliseconds, correct? Then you can see that I'm drawing in the bottom, correct? So in violet color, the pulse width is reduced. So now, because from rich, what we are doing here, from rich mixture, correct? We are reducing fuel. We are reducing fuel quantity towards linear condition, correct? So more fuel if you inject, then stoichiometric, then there will not be no oxygen this and this one. So then you will reduce the injection pulse width, correct? So that's how the closed loop control is done, correct? To maintain the air-field ratio to stoichiometric, closed loop air-field this one. How you for that you have to use one EGO sensor, correct? So many times students get confused, correct? Closed loop control here you can inject fuel even without the EGO sensor, correct? That is called as open loop control, correct? In open loop control, what you do is you program ECU, correct? ECU will read you will not have oxygen sensor at all. In the tailpipe, oxygen sensor will not. You will have, for example, TPSL, throttle position sensor, correct? Which says how much air is going in, correct? This sensor deducts the air quantity went inside the combustion chamber during the suction stroke, correct? So it senses, correct? How it measuring the angle of opening, throttle opening. It gives a so this signal goes to ECU. Now already ECU is programmed, correct? If throttle open 0%, correct? So this much air went. If they open to say 10%, this much air, 20%, this much air, correct? 50% is this much, because it's continuous opening. Throttle is opening continuously. When driver presses the accelerator pedal, this stem, correct? This butterfly valve will be connected mechanically, correct? This is connected mechanically to the accelerator pedal, correct? When driver, correct, sits in this one, when presses using his leg, correct? What happened? When he pushes down, there's a mechanical links, and these links will connect and will turn this butterfly valve. Generally, the valve will be completely closed, ideal condition. Air cannot go in, except the ideal air going in the bleeder. This is a bypass valve. Already told you in the previous class. Now, when you press this, what will happen? This butterfly valve will open from closed condition slowly. correct? So it can become 5%. It is a continuous operation. How much the driver presses, depending upon 0%. When you fully pressed condition, suppose it comes here, it may be 10%. So accordingly, the butterfly valve will open. Because here I am installed the TPS sensor, correct? Throttle position sensor, which gives signal to the ECU saying how many percentage throttle is open, whether 50%, 70%, they are continuous. Accordingly, already you create a map, fuel air map. I am going to show today, correct, how it works. So this map you have to create in the in your company, correct? Here, all companies are in the, if you are doing research, you what you will do is you couple the engine with dynamometer, correct? So engine with dynamometer is coupled, correct? And then you connect your ECU, which is going to control the injector, correct? Inject is connected here. Inject is here in the engine. By controlling the injector, correct? How? By varying the pulse width. Different pulse width for different throttle position, you will create a map. I am going to show today. That map will be stored inside the ECU, correct? In automobile terminology, company terminology, is called fuel maps, correct? Fuel maps will be stored. It is a two-dimensional map, correct? So like this, for example, I am showing. Okay, so this is the throttle percentage, correct? Throttle percentage, okay, 0%, 10%, 20%, like that. It goes up to 100%. That is throttle opening percentage, correct? This is y-axis will be engine RPM, correct? So this is engine RPM. There are different methods. I will show one method, correct? So engine RPM. This is called N alpha method. It is called as N alpha method of fuel control, or air-fuel ratio control. Can be called as AFR control. This is the open loop control. Why I am saying open loop, you will understand. Okay. In the laboratory condition, you connect the engine with the dynamometer, correct? Then you will control the throttle, correct? Throttle will be controlled. You correct, in the laboratory you will control. So the fuel by changing throttle condition, then what you will do is the ECU will inject fuel quantity, correct? So then you create map. The engine will be set at 1000 RPM, for example. This is 1000 RPM. So for 1000 RPM, okay, I am putting here it's 1000 RPM, 2000 RPM, 3000 RPM, like that you can go. Okay, 1000 RPM, correct? 0% idle condition. Okay, generally there's no need to have map. Generally, you may get 5%, correct? You can start with 5% throttle. Idle condition, engine will be running using the bleeder valve, correct? So that time you are not pressing the throttle. Then you can press the throttle to inject more fuel to accelerate, correct? What you do is you are going to inject fuel for more, this one, 5% throttle, 30%, like that. You can go up to. So then you open the ECU, will open the injector for 1 millisecond, correct? Then you will see how much torque is developed by engine using dynamometer controller, correct? Dynamometer controller will be there, correct? You can see the torque. There will be display for torque. There will be display for RPM. There can be display for even power. In dynamometer control panel, you will see three things: engine torque, engine speed, engine power. So three displays, correct? Now, when you keep the engine throttle position 5% and the engine is running at, for example, 1500 RPM, because single cylinder means 1500 RPM itself idle speed, correct? So for example, it's a 1000 idle speed. I put run at 1500 RPM, correct? So then I open throttle for 5%, correct? Keep it there. Then injection pulse width. This injection pulse width will be controlled by ECU, correct? The ECU generates. So initially it may generate 1 millisecond, this pulse width, correct? Now when engine is injecting dust mud, correct, engine develops some torque. So in the dynamometer control panel, you see what is the torque, correct? So torque, then keeping the position, if you make the ECU to open for 1.1 milliseconds, correct? 1.1 milliseconds. There, now that means you are injecting more fuel. You will see that torque will increase. Like that, you increase 1.2 millisecond, 1.4 millisecond. When you do that, if you see the engine torque will from less torque, correct? So it will start increasing. It will start increasing. So this is my fuel quantity in terms of milliseconds, correct? That is, millisecond means your injector opening time. As the injector start from say 1 millisecond, 1.1, 1.2, like that I've increased, you will see the torque in the engine will increase. The torque, this is torque, correct? Torque will start increasing. When I go to particular fuel quantity, say for example 1.5 millisecond, if I open, because I'm increasing the, say this is 1.5 milliseconds, 1.5 millisecond, you will see that torque would have reached a maximum value, correct? This is a torque value max, Tmax. Tmax for 1500 RPM, correct? And 5% throttle. So you fill here with 1.5, correct? The table. Like that, what I do, I run to 2000 RPM. I change the engine in the dynamometer 2000 RPM. So for 2000 RPM, 1.5 millisecond will not produce. Again, torque will be this one. Then again, what you can do is, again, you increase the fuel in the duration, 1.6 millisecond. Again, you will see the torque will be increasing again, correct? Further, it will increase something like this, correct? It will go. When if you go to say 1.7 millisecond, correct? It will give still more torque. So this is, for example, 10 Newton meter. Correct? It may become say 12 Newton meter, correct? For 2000 RPM. So what is it pulse width? It was 1.7. So you fill with 1.75 millisecond. Like that, for each throttle position, increase the speed. You fill the table. This is a two-dimensional table. What the table contains? This is nothing but pulse duration, injection duration. For what? For particular throttle position or particular RPM, you have to open the injector for 1 millisecond. The engine will develop maximum torque. This is called as mapping, correct? That means you see that in the lab condition, you have to couple your engine with a dynamometer, and you have to vary the fuel quantity with the ECU, because there is software available. The ECU suppliers will give. So you can vary the pulse width, correct? Which pulse? This is pulse width, PWM pulse width for each throttle position and each speed, correct? So you have to generate map. Correct. So this is one pulse width, correct? So this is one pulse width, correct? So next pulse width. This is 2000 RPM, same 5%. So 3000 RPM. So for example, your engine can go up to 5000 RPM, means you map up to 5000 RPM. Then what you have to do? Again, come back the engine speed to 1000 RPM, increase the throttle position to 10%. Again, increase the fuel quantity, you'll get one more curve. You find out what is the maximum torque. So that pulse width is marked. So it may be 2 milliseconds. So you mark 2 milliseconds. Like that, you have to fill the table. This is called a fuel map. Right? So in this way, you can control the air-fuel ratio of the port fuel injector system. Correct? Port fuel injection system. This is called, as I told you, fuel maps. Correct? So this you have to generate in the laboratory condition. In a company, you will have dynamometer, all those things. You have a test setup. Correct? If you make an engine, you have to create map. So this is one such map, correct? Like that, you will have different maps. I will tell you what it is when we talk about it. So this is how the fuel injection map is developed in the laboratory. In the research column, I did this. For my PhD, I developed indigenous ECU. I developed the ECU itself. I told you, I developed the ECU hardware. I wrote the software. Then I mapped the engine, which was 125cc scooter engine, correct? I put, because carburetor was removed, I put the injector, correct? I made the manifold. I made this manifold also, correct? After making manifold, all these things. So then I put in the engine was connected to dynamometer, this arrangement. Then I made this map, correct? This map is for max torque. Every time what I'm doing, I am varying, I'm keeping the engine speed one condition, correct? throttle one position, then I am increasing the fuel, the injection pulse width, correct? 1 millisecond, 1.5, this one like this. For particular this one, the torque become maximum. If I increase the fuel quantity further, what will happen? Torque will fall, correct? So that means you should not, that means you are injecting more fuel here because pulse width is here, correct? The pulse width is increasing, correct? Pulse width is increasing, correct? So after 1.5 millisecond, if you increase the fuel quantity, the torque will not increase, correct? But you will see that HC will increase, unburned hydrocarbon, all this things. That means you are wasting fuel, correct? So you should not. So this is the maximum torque condition. So this map, what I created is called max torque condition map, correct? Max torque map for different engine speed and different throttle position. This map will be stored as a inside the programming, inside the ECU, correct? When in the actual engine, if I connect the this engine speed sensor, correct? You have the crank speed. I will delete all those things so you can see it. So you can see that engine crank speed sensor. Somewhere was there. Okay, here it is not shown, correct? Yeah, it is here. Yeah. Using this, you measure engine RPM, correct? Then using the TPS sensor, you measure throttle position, throttle percentage, correct? This is engine RPM, correct? Using dynamometer, I made the map, correct? I told you, we made the map. So this is throttle percentage. This is engine RPM, correct? So we know that this is 1000 RPM, sorry, 1500 RPM, 2000 RPM, 2500 RPM. Like that, I can go. Engine may go because, say, for example, last column, I will see that, say, 5000 RPM or 6000 RPM, correct? I'm in steps of 500 RPM, correct? Similarly, here, 5% throttle, 0% idle condition, correct? 10% throttle, 20% like this, you can go up to 10% throttle, correct? So you vary the injection pulse width, find out what will be this each cell, correct? Each cell is filled with the millisecond duration. Injection to what is the injector should be open, correct? So I say that this is 1.5 millisecond, this is 1.75 millisecond, this is 2 milliseconds. So for example, 2.8 milliseconds, something like that, correct? Next time, 10% throttle, I say that it may be 2 milliseconds. So 2.4 millisecond, 2.7 millisecond. So for example, 4 millisecond. Okay, 3 millisecond. Like this, for 10% throttle, it may start with 3 millisecond, correct? End up with, for example, 6 milliseconds, something like that, full throttle condition. So you fill all this. This is called a fuel map, correct? So this will be stored inside ECU. Now, in the engine, in the actual vehicle, you what you will have is this the TPS sensor. So this TPS sensor and the crankshaft sensor alone will be there. So when engine is running, these two are connected to ECU. ECU sees what is the engine RPM, throttle percentage opening and the engine RPM, correct? And based on this data, this is called as a lookup table. Engine maps are lookup table. It is called as lookup table. Okay, this lookup table will be stored inside ECU. So when the ECU receives signal from the TPS sensor, correct? This sensor, correct? A proportional voltage, 5% throttle means a voltage will come, because the TPS sensor we are going to see that it will generally produce, say, for example, 0 to 5 volts, correct? When throttle is fully closed, it will generate 0 volts. When throttle is fully open, it will generate 5 volts. So if you see the map, correct, throttle position sensor, 0%, 10% throttle, correct? So here 0 to 5 volts. So it will generate a linear line. This voltage will be connected to ECU, correct? TPS will be supplying this voltage, correct? So based on this voltage, correct, if 0 volts means the ECU knows that throttle is in idle condition, engine is in idle condition. When if it receives 5 volts from a TPS sensor, it knows that throttle is full condition, correct? Full condition is it has to see this column, correct? The next, what is next one? It has to see engine RPM, correct? Engine RPM sensor, this sensor, correct? This engine RPM sensor also provides the speed in terms of voltage or number of pulses. So the ECU measures the RPM. So the engine RPM also will be another this one. When the engine is running with zero condition, correct? Zero RPM, it will not produce any pulses. When it start running, starting from, we know that it is always not from zero, generally from idle RPM, correct? 1000 RPM or 1200, 1500, depending on engine, correct? So to, for example, 8000 RPM, that is engine maximum speed, for example, correct? So for that, it will produce some voltage, correct? So the crank angle sensor, correct? Engine speed sensor will be may produce a voltage 0 to 5 volts, correct? This is 5 volts, or it can generate pulses, correct? It can give pulses. So the EC will count. We will see about when you talk about sensor result. So now, based on this voltage, whether 0 volts means it is idle. When it is receives 5 volts, it is 8000 RPM. So any voltage coming from the sensor, EC knows that engine is running at particular speed. So once these two values are known, correct? I will draw in different color. I will also. So based on the voltage, this is represent 0 to 5 volts by the RPM sensor. Similarly, this is represent 0 to 5 volts by TPS sensor, correct? So based on that, the ECU will select what should be fuel injection quantity, how long injection should be opened, correct? The injection pulse width, correct? So whether 1.5 millisecond, 1.7, 2 or 2.5, whatever it may be. So as the driver is pressing the throttle pedal, correct? TPS position voltage is varying. Because of that, fuel is injected, engine speed increases, the engine RPM sensor senses. These two voltages are coming to ECU, correct? ECU will be able to control the fuel quantity based on this map, correct? Please see that in this case, it is not using EEGO sensor, correct? EEGO sensor. This is called an open loop control. Open loop control. In open loop control, open loop air-fuel ratio control. How you are done? Because air-fuel ratio you wanted to control, you generate a map where in the lab, correct? Company map, when you company manager, there will be test cell or test bed where you connect the dynamo to engine, and when the engine is designed, finally you have to create map, correct? Now this map is stored inside ECU. We will put on the ECU will be put on the actual engine. Where what you will have? You will have two sensors. Only crank speed sensor, which gives the engine speed, and the TPS sensor. Of course, injector will be there, correct? So only with the two, this one, if we connect it to ECU, which is installed in a vehicle, by looking at this map, the engine, the ECU will control the fuel quantity by varying the fuel injection pulse width, correct? Which is called a pulse width modulation. But this is open loop condition, correct? Now, due to some reason, like the atmospheric temperature variation, correct? Atmospheric temperature variation, correct? The air density changes, correct? Morning time, what is the temperature? Temperature may be 30 degree, correct? When the map was created, this map was created in the test cell, correct? But you know that in case of your company, you will say that it will be a ultra modern facility, correct? It is called test cell, where the air temperature, air humidity, correct? Pressure inside test cell, where engineer, it will be a completely enclosed loop, correct? Inside it, engine dynamo, all these things are fixed, correct? You will have the humidity control, correct? Temperature control, the pressure inside that room, test cell room, it will be tightly closed, nothing can leak, correct? You can control all those things. You can create any condition, whether it is a sea level, correct? Sea level, the pressure will be 1 bar, correct? That is a sea level, 1 bar pressure, correct? And but the moisture, correct, maybe more, correct? Humidity maybe 85%, correct? And temperature, for example, take Chennai. If I am driving my motorcycle car in Chennai, when I start my car in the morning, correct? For example, in winter, correct? Now it is around 28-30 degree. In the afternoon, it becomes 35 degree or 34 degree, correct? Then again, evening it falls, correct? So when air falls, what will happen? How did you decide the fuel quantity? In the laboratory condition, you change the throttle position, correct? you change the different throttle position, 5%, 10%, all these things. You can set the control the engine speed using dynamometer. Then you are varying the fuel pulse with it, correct, for max torque, correct. When the torque, because I told you, as you inject the fuel quantity, correct, pulse width, you do that, the torque goes to a maximum value. You have to stop. That's what you filled. This is open loop, this one. Now, if I run, this engine was tested at 30 degree. You did, for example, you are doing experiments in open lab, because when I did PhD, correct, I was doing, because IIT IC engine is not, we didn't have test cell, correct, where I can control temperature, room pressure, correct, all these things is open lab, correct. Morning it was 30 degree, correct. I'll be running for to take this map, it may take 1 or 2 hours, correct. You have to put a different the throttle position, correct, and set the engine speed. Engine should run for a few minutes to stabilize. You cannot take the reading immediately. Change the throttle 5%, engine goes to RPM, immediately should not take. You have to give stabilization period to create map. So we have to wait for 2-3 minutes, so that engine, we have to see whether engine is running 1500 RPM, 5% throttle is there. You lock the throttle knob, all those things, and you wait for a few minutes. Then engine is in stable condition. That time I will vary the fuel quantity, pulse width, correct. I vary the fuel pulse width from 1 millisecond, 1.5 millisecond vary, which takes almost 5 minutes. Correct, 4 to 5 minutes happen to take one reading. Correct. For example, my table had, for example, I did for 1500 RPM, 2000 RPM, 2500, 3000, 3500, up to 4000 RPM. Correct. I did for different throttle percent, 10%, 20, 30, 40. So you can see that almost the number of cells will be around 8 by 5. Correct. 8 by 5. So 40 readings I have to take. Each reading takes 5 minutes to engine stabilization, then adjust the pulse width. I have to see in the dynamometer where is the maximum condition. Correct. Once I find, I fill the value. Correct. I filled all the 40 value, took 2 hours. I started by 8 o'clock, by 10 o'clock. Even within the time, the room temperature, atmospheric temperature vary from 30 to 33 degrees something. I still remember, because I was doing in 2003 or 2004. Correct. So now now I created, but please note that if the temperature increases, thinking that, because I don't have test cell, no other option. So I try to do all the experiments quickly. Early morning come, before sun becomes very hot atmosphere. I try to compress. Sometimes I come by morning 6 o'clock also, because even if sun rays happen 6 to 8, temperature rays will be very less. Correct. Sun is in the horizon. Correct. Temperature will not change. After 8-9 o'clock, when temperature will start shooting up quickly. Every hour temperature will increase. So my temperature will be within 30, 31 degree, 32. I take it around 32 average value. Then I vary the pulse width. I create this map. This map was valid. Correct. This is called calibration. This map creation is called as calibration, or lookup table creation, or fuel map creation. Correct. These are different names used by companies. I create a fuel map, but this fuel map will give max torque at what temperature? At when atmospheric temperature is only 30-31 degree. Because I put my ECU in the actual vehicle. Actual vehicle, you are not going to drive inside the test cell. It has to be driven inside open space. Correct? From Chennai, I may be roaming around. I may go to Bangalore. I may go to Kodaikanal, Ooty, hill station. Correct? I can go to Rajasthan. Correct. Same vehicle can go to Rajasthan, desert condition. In desert condition, early morning itself will be 35 degree, 30 degree. Correct. Correct. Midday it may become 40. So this fuel map which I create always gives a max torque map is valid where only when the atmospheric temperature 31 degree or 30 degree approximately, and at sea level. Correct. Sea level, what is the pressure? 1 bar pressure. Correct. At 1 bar pressure, at 30-31 degree temperature, this map was able to, if I keep the engine at 1500 RPM, 5% throttle, if I open the injector for 1.5 millisecond, my engine was giving maximum torque. Correct. That is fuel efficient. I want maximum torque. Correct. So that for less fuel, I will be able to drive vehicle for more distance. Correct. With 5%. So this fuel map is valid. Calibration is valid only for 1 bar pressure. That is if I drive my vehicle near seashore itself, Chennai, Vizag, correct? Anywhere, Pondicherry, always in this place. And that also when temperature is around 30 degree or 31 degree. Correct? So now, but we know that it is not possible. in Chennai itself, if I drive the same vehicle engine, which is installed with this fuel map, morning it is okay because I create a map at 30 degree at 1 bar. So the same Chennai, the same beach road I drive in the 1 o'clock, correct? So the temperature become 38. If in summer it can become 42. Then what will happen? Air density. When temperature increases, air density reduces. Then for the what is my engine CC? I said, for example, I mapped for 125cc motorcycle, scooter engine, correct? So 125cc more, this one, when suction stroke, the volume created is 125cc, correct? What is the airfield ratio? Airfield is always talk mass of the fuel, mass of the air divided by mass of the fuel, correct? We call it a lambda, correct? So 14.7 is to 1. Correct? The 14.7 is the air mass. Correct? But air mass for a given volume, 100 cc mass is proportional to, we know that PV equal to nRT. Correct? What is this? Ideal air equation. Correct? Ideal gas equation. Correct? Where V is the pressure, V is the volume, given volume, N is a constant. Correct? R is also constant, T is the temperature. Correct? In this, now, in this, we know the temperature was 30 degree, correct? This pressure was 1 bar when I took the map. Volume was 100 cc, correct? Now, for that, so many grams of air was there, correct? Say 14.7 grams this. Now, if temperature increases in the afternoon from 30 degree to 40 degree, correct? But the engine volume is fixed, 125 cc engine only, correct? It is already designed. When the piston goes to BDC, correct, the combustion chamber volume, when this one air sucked will be 125 cc only, volume wise, correct? But its density will reduce because the temperature increase. If density reduces, mass of the, correct, mass of the air become less. That means this map is not valid. You got it? The map created for max torque condition at 30 degree temperature at sea level, 1 bar pressure at sea level is not valid even in the same sea level in the afternoon condition because my temperature went to 40 degree or 35 degree, correct? So that means this airfield ratio or the map created is not going to work when atmospheric condition changes. Can you control atmospheric condition? Nobody can do because my vehicle will be driven open condition. Can you control the pressure, temperature of the atmosphere? Nobody can do, correct? So this is the major drawback of open loop control. Open loop control, correct? Drawback is the fuel map created is valid only for test condition, correct? So then how do you do that, correct? If you want to control airfield ratio properly, then you have to put exhaust EEGO sensor in addition to throttle position sensor and engine speed sensor, correct? You have to measure exhaust oxygen and that also given to this one. So by measuring exhaust oxygen, you can maintain what you call closed loop airfield ratio, correct? Closed loop AFR control is possible. Open loop airfield condition, you don't need oxygen sensor, only you have throttle position sensor, engine RPM. You create a map in the test bed. But in case of, if you wanted to maintain the same airfield ratio, irrespective of the atmospheric temperature, atmospheric pressure, when the pressure changes, if vehicle is driven from Chennai, I take it to Ooty, correct? Say it is 1500 meter, 1000 meter height, Kodaikanal, something like that. I go to Himalaya, temperature varies, cold condition, denser air, correct? If it varies, to compensate whatever happens due to change in the pressure of the air, when the vehicle is driven from sea level to higher level, mountain level, higher atmospheric conditions, or at higher temperature, morning to evening, correct? Daytime, summer, desert, all those things, by giving a closed loop control, measure the exact oxygen level, you can control the closed loop airfield ratio, correct? But problem is you have to put additional sensor apart from the throttle position sensor and the engine speed sensor. You need to provide exhaust oxygen sensor. So this sensor is also going to increase the cost of the total electronic fuel injection system, correct? So that's how it works. Okay, closed loop control. Okay, now we'll go to next slide. Okay. So this is called as port fuel injection system, correct? PFI. The short form is called PFI. What is the PFI? You have a single cylinder engine, correct? Where the fuel is injected at the inlet port outside, correct? You can see the from injector, this is the inlet port, correct? This is the inlet port. Inlet port. Outside the inlet port wall outside surface, right? So the advantage is because inlet valve itself get heated up to 200 degrees centigrade. When engine starting, it may be room temperature, correct? Engine starting, it may be room temperature. In the winter, it may be 0 degree also in Delhi, correct? In Chennai, it may be 80 degree. In IIT, correct? Lot of trees are there. So engine, the valve temperature, the entire engine will be at atmospheric temperature. Correct? It can be 0 degree to maybe 30 degree morning temperature, depending on location where you are inside India itself. But once you start, engine is started because combustion is happening, correct? Combustion is happening inside the engine, correct? Combustion is happening inside the engine, correct? So this engine will get heated up. Engine valves, this valve, correct? All this thing will heated up, correct? So after a few minutes, if engine is running, this temperature will be around 200 degree. Correct? This temperature 150 to 200 can be depending on engine size, all those things. Correct? So 150 degree. Now, if fuel is injected compared to room temperature 30 degree or 40 degree, 150 or 200 degree very high. Correct? If fuel is injected, immediately all the fuel hitting the surface of the valve will vaporize. Correct? The fuel will immediately vaporize. Correct? It will vaporize. So that means we want, correct, better fuel vaporization. You will get homogeneous air fuel mixture. Correct? Homogeneous air fuel mixture inside the engine. Correct? Please note that injector also injecting only liquid fuel, but small, because while injecting this one, it becomes small droplet, micrometer, I told you. Correct? So those fuel will be injected, just comes out. Okay. We can see the fuel is injected, and because the outside the inlet valve surface will become around 150 200 degree after 1 or 2 minutes engine warming up, correct? All the fuel, most of the fuel will evaporate. Maybe some amount of fuel may be sticking here at the manifold. Those fuel will not vaporize, correct? Those fuel will not vaporize. Okay, I think 5 students or 4 students left this one. Why they are leaving even before class ends? Some of the students left themselves. Some students joining after half an hour. Some students are leaving even by 6:40 itself. 6:40. This is even before class ends. This is not acceptable for me. You have to attend full class. You should maybe 5 minutes plus or minus. Joining classes by late, going out before, all those things is not correct. Will you do in a regular class? If you're sitting in the classroom, just walk out. The class representative may advise the student not to leave the class before the class ends. Similarly, they have to join the class within 5 to maximum maybe 8 minutes, not after that. Because I can control. In that case, I can say that you cannot log in because Zoom gives a provision to stop. Tell the student they have to join, they cannot leave just like that, and they cannot come late also. Fine. Okay, so this is open loop, and this is called PFI. Open loop controller PFI or closed loop controller. Closed loop means you use exhaust oxygen sensor. Open loop means you use only crank sensor and the TPS sensor. Only two sensors are used. Okay, so now this is the advantage. This is called PFI. Why? There is single cylinder, port is injected, fuel is injected on the inlet port. So next slide shows what you call as a MPFI, correct? MPFI means you will have multiple cylinders, correct? The same thing is shown here. Here one cylinder is shown. You will have multiple cylinders, correct? For example, car engine, 4-cylinder, correct? For each cylinder, you can see that there is a in this figure you can see the fuel tank. From fuel tank, the fuel is sucked by the fuel pump. Correct. Generally, it is an electric operated fuel pump working at 12 volts or 24 volts, depending on what is battery available. Then pressurized fuel is sent to the fuel filter, which will remove the dust, all those things. Then the fuel goes to what you call as a accumulator or rail, fuel rail, correct? It is called as fuel accumulator or fuel rail, correct? It is nothing but a cylindrical tube, both ends is closed, correct? Of course, there is a pressure sensor. I will explain what it is. Just 1 minutes, I will close this line, correct? So if multiple cylinder there, from the fuel rail, you can see the pressurized fuel is coming here to the injector, correct? This is injector, first cylinder. Similarly, in the second cylinder also, you will have one more injector, correct? That injector will be connected to this fuel. Then for third cylinder also, there will be one more injector that will be connected to fourth. Then similarly for the fourth cylinder also, correct? You can see that. Now you have common fuel accumulator, fuel rail, where the pressurized fuel coming from this will be stored. Fuel will be stored here, correct? So this may be having some 50 cc or 40 cc or 100 around that, correct? More accumulated. So whenever then ECU will open each cylinder depending upon the suction stroke, correct? During suction stroke of the each cylinder, ECU will open this injector, the fuel will go to this first cylinder. Next, this will be closed. The next cylinder will be suction stroke. We know the multi-cylinder engine, all cylinder will not be its suction stroke one after another, because you know that the four-stroke engine, you have 180 degree, 180 degree, 180 degree, 180 degree, correct? So this is for first cylinder suction stroke, cylinder 1, correct? Second cylinder suction stroke, third cylinder suction stroke, and fourth cylinder suction stroke, correct? So for each, during that time, each cylinder will be open, correct? So that time fuel will be. So since fuel is injected multiple point, it is called MPFI, correct? Multi-point fuel injection system. This will happen only if you have multiple cylinder. If you have a single cylinder, you will use only PFI, port fuel injection. If you have multiple cylinder, sometime in some books they call multi-point fuel injection system, correct? This is 1-point fuel injection system, first cylinder. Second point where fuel is injected for the second cylinder. Third point, fourth point. Or some book they have multi-cylinder, multi-point, multi-cylinder fuel injection is called as MPFI. With this, I stop. Tomorrow we'll continue. Thank you very much.
Thank you, Professor.
Yeah.
Thank you, Professor.
Okay. Bye.
Thank you, Professor.
Thank you, sir.
Thank you.